Charles River Museum of Industry and Innovation. Evidently, there was a bicycle manufacturing company in Waltham called the Orient Bicycle, and this is a 10-person racing bicycle. Some of the history of the Waltham Watch Company, some of the tools they used to make watches. Little miniature lathe. Neat stuff. There's a typical watchmaker's bench. All the tools. The lathe. Banjo clock. This is what we're here to see today. 20th annual New England Model Engineer Show.
Is that like a squash plate? No, it's an elbow engine. Yeah, one's pushing up and the other's pushing out. And then it rotates. What happened? I was built in my mother's under the
like those little hit or miss engines that you see at the state fairs.
Yeah.
Look at that take off. Thank you. This one is too. Yeah. This one's on hold What's really unique about these is they're not hooked up to any air compressors or anything. They're strange little engines that they have the ability by putting heat on them or doing something to them that they run.
Oh, I see.
These are called Stirling engines and they run by pressure differential.
I mean, they just keep running for no real energy.
That's what it looks like. I think there's a little bit of a flame. See the flame on the end of it?
Oh, yeah.
There's a little bit of a flame on it. So heat is causing it to run.
They have a similar kind of software that runs on the computer side called processing. And so I can program the Arduino here to take the data, put it into little packets to send up to the serial board, and then I program processing to take that, calculate volume, and draw a little line segment on the screen. So I had to draw all the line segments myself, except for the text.
Yeah.
They give you fonts and stuff like that.
Very impressive.
Yeah, and it's a lot like C. It's not like programming C.
What is the theory of operation? What is making it run?
Well, this is an atmospheric engine, otherwise known as a flame licker. And basically what happens is this flame here, I don't know if you can see it, but there's a valve right here. So when I get to a certain point, the valve opens and it sucks the flame in.
I get you.
Sorry, it sucks the flame in. There we go. And then the valve closes and that hot air inside contracts because it's cooling off.
Right.
It creates a vacuum and sucks the piston back in. So the power stroke is a vacuum stroke rather than a pressure stroke.
Okay.
So I give it a little spin and away it goes.
That's amazing.
And then this is a pressure transducer that detects what the pressure is inside as it happens. And then this is an encoder that detects what the angle of the crank is, so you can calculate what the volume of the piston is.
Okay.
I take all that data and put it to the computer, and you end up plotting it here and getting what's called an indicator diagram. The area inside this curve represents the energy on each stroke. In this case, it's about 150 millijoules. You multiply that by speed, then you get power. Now, that's the power at the piston. The problem is then you have to push it through all the friction in the engine. So the engine doesn't go very fast because the power it's making is barely enough to keep up with the friction in the engine. Right here, I have a little chip of wood in here between the cylinder and the fins. And I've wedged a thermocouple in there so that I can see what the temperature
I was looking at that, yeah. Pretty neat. Thank you for that.
You're
Appreciate
welcome.
it.